guys. One of my subscribers has asked that I write a video up on multi-threading examples for the Delphi or Pascal programming language. So big thanks to him for asking about this. This is actually a really important thing to discuss in programming. A lot of people get really confused about it because programming in parallel can get, well, pretty technical at times, especially when you're dealing with large data types and stuff that needs to happen like at the same time, most especially with graphical interfaces like this one, where, if you have like a lot of components on the form or in your project that need to be graphically updated, like say when a thread terminates or even during a thread's running execution. We're going to be going over all of this stuff, but to start with, we're going to start with TTask, which is kind of a cheap out way of multi-threading. So just to reiterate, guys, we're going to talk about TTask, and we're also going to talk about actual multi-threading. Now, TTasking is multi-threading, but it's just extremely simplified. It's kind of a Delphi programmer's way to cheap out and make a multi-threaded application, but not do so much work. There's not a lot of overhead for it because all you basically have to do is call TTask and then do a procedure and boom, you're done. And that's what we're going to discuss during this sample. And so there's going to be two samples. There's going to be this TTask example, and then there's going to be an actual multi-threading example, fully fledged with a constructor, a deconstructor, an execute method, and synchronization. So let's go ahead and start with the TTask here that we have. So what I'm going to do is I'm going to get some progress bars thrown on here. So there's 1, 2, 3, 4. This is the best way that I know how to explain to you guys, like multi-threading in Delphi, is just to show an example of something that's logically showable. Like that way you guys can visually see this stuff. So let's go ahead and try to get these lined out as best we can. Anyway, so now we're going to get some buttons, and we're going to go with a standard button. We're going to put that right here. We're going to put that right there. We're going to copy, and we're going to paste, and paste, and paste. We're going to drag all of these to the far corner as far as we can. Go with it. We're going to resize this form down to this. We're also going to grab ourselves a label. The label is going to be used to display how many active concurrent threads are running in our process. So we're going to actually put, for the caption of this, let's just put active threads 0 to start with, since we don't have anything running, right? Now I'm going to pull this down a little bit. I'm going to make this font size a little bigger so we can see what we're looking at. I'm going to put 12. That seems like a pretty good value to me. Looks pretty decent. Yippee-ki-yay, there we go. All right, so there you have it. Let's go ahead and theme this bad boy up. Let's go to Project, Options, and we're just going to apply just a quick theme so we're not looking at something ugly the whole time we're developing, because I can't stand doing that, by the way. So let's go to Appearance, and let's give this thing, let's just look around. How about we do, let's do Aqua Graphite. So there's Aqua Graphite, and as you can clearly see, we are now themed up and ready to roll. Let's go ahead and select all the buttons. So just hold down Shift and select them all. Let's change the caption of all these to Start. All caps. All right, so now we've got a basic graphical interface. Now what we're going to do is each of these buttons is going to be responsible for creating a new TTask thread, and each of those threads is going to be responsible for making these progress bars step up, meaning progress, right, to the end, to 100%. And as they do this in the background, it's not going to affect the main VCL thread at all whatsoever. It's also going to update everything in real time, including the button will be disabled whenever the progress bar is actually running with the thread, and whenever the thread finishes, it's going to update these back to being enabled so that we can start all over again. Now, the entire time this is happening, the label is going to keep up with how many threads are actually running in memory. And whenever the threads end, it's going to decrease properly to show the exact amount of threads that are currently actually active, obviously. Okay, so to get things rolling on this, let's go ahead and take care of just a couple of precursors. At the top of the code, let's add math to the uses statement, because we are going to use the min function for the progress bar and stuff, and I just want that out of the way. So go ahead and add math to your uses statement. Now, to get going on this, what we really need to do is go ahead and basically start programming with the buttons to go ahead and create the TTask stuff. But in order to do that, we also need a couple of different different things for updating the graphical interface whenever these things are finished. I'll try to go as best in order as I can, but let's go ahead and just create a private variable right here. We'll call this active threads. So let's do f active threads as an integer type, because we're only going to have 4 threads possible running at any given point in time during this application, because I've only got 4 progress bars, right? So we're going to create an integer to hold how many active threads there are, and then we're going to, we're just going to dive straight into this and start programming, okay? So whenever the program starts, let's go ahead and go to the onForm create event procedure. When the program starts, we want to say self.fActiveThreads is equal to 0, because there's obviously nothing started when the program runs, first off, right? So now that we've done that, let's go ahead and start programming our buttons, okay? So on the first button, this is going to be responsible for starting a T-thread or a TTask thread, and it's going to be responsible for the first progress bar, right? So let's go ahead and double-click the button to go to its code, and we're going to start writing some code. So I can already tell you that the first thing we're going to need to do is reset the progress bar if needed. Now, I'm not going to do an if-then statement or anything special, guys. I'm just going to keep it really super simple. We're going to say self.progressbar1.position is equal to 0, because we're going to restart everything, right? Now, what we're also going to do is disable the button. Disable this button. Self.button1.enabled is equal to false. Okay, now we're going to actually start programming our thread, okay? So a lot of you guys out there are probably thinking, you know, hey, multi-threading is pretty tough sometimes. In this case, again, like I said before, this is just a T-task. We're cheaping out big time, okay? This is kind of the lazy way to program with multi-threading in Delphi, okay? You just make a task and make Windows run it. So this is how it works. You're going to essentially just put TTask.run, and then we're going to run whatever code we would like in its own procedure. So the thing about that is, oh, I'm sorry, guys. I see that it shows red here. This is because we forgot to add our uses statement. So let me come in here, and it should say threading in here somewhere. Ah, I see, that's what's missing. So you got to add system, like this, threading. So make sure you add math and system.threading to your uses clause statement before we do this, okay? Now you can clearly see that we're able to start doing stuff, and it's asking us for a few things. It's asking us for a notify event, it's asking us for a thread pool, tproc, and you know, whatever we want to put in there. So in our particular case, essentially all we're going to be doing is we're going to be looping, we're going to be making the thread essentially loop and continuously add to the progress bar, like 10 at a time, step by 10, load by 10, so 10, 20, 30, 40, 50, 60, 70, 90, 100. Then we're going to make it update the thread on the, on the label, on the thread count stuff, and then we're going to make it at the end, when it's completely finished, we're going to essentially make it, re-enable the button and whatnot. So in order to do this, we need to go ahead and safely, here, let me undo that. We need to safely be able to lock the number of active threads. So we're going to put interlocked increment, and then we're going to put the appended integer, which is going to be our active threads. So f active threads. Okay, then we're going to need to, and I'm gonna put a bunch of comments here so you guys will understand what's happening. Okay, so I'm gonna start here. We're gonna put update number, update active threads label to show how many threads are currently running. So then we'll do that, and then underneath this, we're going to update the progress bar over and over and over until it's 100%. So that'll be for that, and then underneath that, we can then again interlock decrement instead of increment. We'll decrement the f active thread count. So we'll say, and I'll just go ahead and write this code right now, interlocked decrement, hope I spelled that right, and then we will do the f active threads. So now this is kind of creating like a lock, if you will. Let me make sure that this is it's no overloaded version. Oh yeah, I haven't finished my code yet. Okay, not a big deal. We're going to simply put, we have to create a procedure here, guys. So procedure, and we have to begin and end just like you would in a Delphi-based application. So I'm going to go here and end it out with that. So now we actually have our thread that we're able to do stuff. So let me make this very clear to you guys, okay? This is a thread, okay, for all intents and purposes. Everything inside of this, between this begin and this end, is going to happen in parallel. It can possibly happen in parallel. It's happening inside of its very own thread in the background, okay? So anything that happens outside of this zone, to be able to update the graphical interface, we have to design a system to be able to synchronize that information. Now, just keep paying attention because it's going to get a lot easier here in a minute, okay? So if you're with me so far, just understand the two things. This is a thread. Anything that happens inside of this thread is in its own worker thread. It's happening behind in the background of our main executable process, right? Now we can call this 1,000,000 times if we wanted to by rapidly clicking the button over and 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 over, and it keeps making a new thread, new thread, new thread, new thread, new thread. You get it? You starting to kind of get that? Okay, so what we're going to do is we're going to lock the incremented thread count for this particular thread. Then we're going to come on down and we're going to update the thread's label. So to do this, the TTask run procedure or method in Delphi can actually synchronize things automatically as long as you program a procedure that can handle whatever you're trying to do. So I can't just say, I don't believe I can actually just say synchronize and then like type in, label dot update, whatever we want to do there. It won't work like that. So what we have to essentially do is design our own like little thing that's going to make it work, right? So in order to do that, we have to create our own procedures. So let's go ahead and do this down below. Just outside of the button, outside of everything, you have to make a new procedure for this form. I'm going to call this procedure tform1 dot, and let's just call this thing update active threads label. That ought to do just fine. And then we have a begin and an end. Now, you're going to notice that this is red. This is because I didn't program it into the top of our code for this application. So you have to scroll all the way to the top, and you have to go under private or public. In this case, I'm going to go ahead and just do this in private. So we already have an active threads integer counter. Now I'm going to add the procedure for which we just created, and I'm going to add in update active thread label, just like that. That's all you got to do. It's really quite simple. Okay, you kind of follow along with what I'm doing here, guys. Now check this out. Check this out. All I got to do is copy that, right? And we're going to update the active thread label. So there you have it. It's literally that simple, guys. We're just going to start our thread. We're going to increment the thread count to where it goes up by 1, and decrement down when it's finished. So again, let me increase thread count when the thread actually gets started, okay? And that's going to increment it by 1. So if the thread count is 0, if you have no threads going, then 1 thread is going to exist because it's there. And we're using active threads as a globalized private variable for this application, which is outside of the thread count, so that the label can actually be updated with the proper amount of threads as they're running, right? So now what we're going to do is we're going to update the threads label. So whenever we want to do that, we just simply want to come down inside of this procedure, which is going to now be synchronized to the graphical interface from this threaded task, and we're going to update the label. So just simply say label1.caption will be equivalent to active threads, and then we're going to int to str, int to string, and then f active threads. That's it. It's that simple, guys. I mean, look how easy this is, right? So this is like super cheaping out on multi-threading. It's easy as hell. So now that we've got the ability to add 1 to our thread count and then update our label to show that this thread is currently running, we want to go ahead and start updating our progress bar. Once thread is complete, decrease the number of active threads down by 1. Here, I'll just put 1. There you have it. So that's how that works. And then we're going to update this. So in this, we're going to need to update the progress bar by like 10, 20, 50, whatever you want to make it animate as. Like if you guys want to make these animate, if you want them to go halfway and then finish, that's only 2 ticks. If you want it to go 10, 20, 30, 40, 50, 60, or 5, 10, 15, 20, you get the point. I think you get the point. So for this, again, it would be a lot better if we could animate it a little bit better, like at a lower value, so it actually looks like it's doing something. So inside of the thread, we don't want to just do it all in one go. So we are going to create another procedure for this, okay? So in order to do that, we need to create another procedure up in our private declaration. So I'm going to do it proper this time. Let's make sure to do it up here. So to make a procedure that is going to be responsible for updating the progress bar, we're going to create procedure, and then we're going to do update progress bar, just like that. And the progress bar is going to be a type of tProgress bar. And then we're going to use an increment value of integer type, increment integer. Okay, just like that. So there you have it. This is going to be what we're going to use as this. So we have the ability to have our progress bar type variable, which we're going to pass through to whatever progress bar we're messing with. And we're also going to increment it with this integer value, right? So what I would like to do at this point, let's try running this. I'm actually getting an error, and I'm a little bit curious as to what this is trying to tell me. I do not unsatisfied. Hang on one sec, guys. Pretty sure it's just unsatisfied because there's nothing down here yet. So I'll go ahead and write this in. So down at the bottom level here on our stuff, let's go ahead and begin writing our actual procedure. So I'm going to put this just above this one. So procedure will be equal to tform1 dot update progress bar, and as you can see, that just kind of instantly fills in for me, which is great. Fantastic, absolutely, yay. And then we're going to create a begin and an end, and we're going to start doing some stuff. Let's see if that, yeah, see, that actually fixed the issue. It was an unsatisfied forward declaration because I didn't have the procedure created down below for it to be satisfied with. Anyway, all right, so what we'll do is we're going to say, we're going to have to check its position and simulate work being done. Like, so for example, the ticking and animation of the progress bar filling up. So let's say while the progress bar dot position is equivalent to, let's do, you know what, let's not do that. Let's do less than 100. So while it's less than 100, do begin. And this is where we're going to actually make the magic happen. So while the progress bar is filling up and it's not reached 100 just yet, we're going to sleep for, say, 500 milliseconds, which is half a second. This is going to simulate work. So simulate the progress bar moving up to 100%. Then we're going to go ahead and do a TThread queue, which will then allow us to create yet another thread which queues the process of incrementing the progress bar in another thread that updates our main task. So we're creating a thread inside of our task. So we'll do it like this: tthread.queue, and inside of this, it's asking for the tthread. We don't have one, so we're just going to put nil, and then we're going to put like this: procedure, begin, end, and then we will have this like that. Here, we'll just do it like this. So inside of this, inside of the begin and the end here, we're going to, let's go ahead and put an ending thing here and see if that works. It should. Okay, so Control D. So now we have our own thread. This is the thread that's responsible for updating the progress bar, okay? So inside of this, you just put progress bar dot position is going to be equivalent to a min of the progress bar dot position plus increment of this 100. Now, let's go down. So it will increment to 100. Okay. Now we're going to say if progress bar dot position is equivalent to 100, then we can simply say progress bar dot enabled is equal to false. Okay, that should do it. Let's save that, and let's focus on what else we have to do, because we're not finished just yet. We're going to update the progress bar. So let's take this, okay, and let's go back to our button code, which is going to be right up here. So if you remember, if I double-click the button, take us to our code. This is where we're working inside of this right here, right? So remember, we're going to update the progress bar. Okay, so what we got to do is update the progress bar. And it's asking us for a progress bar type and an increment to use. So we want to use progress bar 1 and an increment. Let's do 10 for the increment. That way it goes 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? So there's that. And now that we've done all of this work, so let me get this straight with you guys, okay? You've incremented the amount of threads that are currently active. You've updated the thread label to display that we do have a thread active. We're in the process of updating the progress bar with inside of our thread in memory, and it keeps going until it's 100%, and it does it step by 10, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And once it's finished, it will display the active thread count again, which is decremented by 1, which is what we hid here when we added 1. Now we minus 1 when the thread is complete. But we also have a couple other things to be doing here. So to do this, we have to re-enable the button that we clicked. Because see, look what I did here. I put we're going to set the progress bar position to 0 to start with. We're going to enable the button to disabled, so the button becomes disabled. So now, at the end of everything, when everything is completed, we have to re-enable the button so that we can retry and rerun a thread again. So what we'll do is we'll say, we can't just simply put button1.enabled equals true. I mean, we could try it, it might work, but it's probably going to give issues because we're not going to synchronize that thing properly. So what we really need to do is make yet another procedure to re-enable a type of button. So what we can do is go to the top here, and in private, we're going to make a new procedure, and this is going to be called enable button. And it's going to have a button as a T-button type. Now, what we have to do is copy this, and we're going to go down to the bottom near here, and we're going to make a new procedure of tform1.enable button, and it's going to have that. And then inside of here, we're going to put button.enabled is equal to true. Now, so we have to pass the button type to this procedure for it to enable the button. So inside of our thread unit, or our task run procedure at the bottom, when it's completely finished, for this one, for example, we actually want to put update button self dot, well, we'll just do button 1. And that's it. That is literally it, guys. So re-enable the button we used to start this thread. So at this point, let's give it a run just real quick, guys, just to see what happens, just to see if we've done it correctly or not. So let's save everything. Let's set the position of this application to run in the center of the screen. And let's give it a run, just for shits and gigs, just to see if I did it all right, just to see if it works. So if I click start right here, it says there's one active thread. And it looks like it worked, but it didn't decrement the value here. So let's go take just a quick look at this, okay? Because if we are going to do this, we want to make sure that we have actually put this in here. And as you can see, I forgot it. See how I update it here, but I didn't do it down here? So you just want to take this, and copy. I'm actually going to copy both of the comment and the code just so you guys can see. So before we enable the button, I'm going to re-update the thread label count. So now we'll try this again, and it should be theoretically fixed. So as you can see, we have one active thread, and it finishes, and then it goes to 0 and re-enables the button. That's it. Great. So now what we can do is we can copy all of the code inside of button 1, and I'm just going to copy literally the entire begin to end, and we're going to double click the button 2, and we're going to add all of our code. Then we're going to go to button number 3, and we're going to add all of our code, and we're going to go to button 4, and we're going to add all of our code. Now we're going to go back up to button 2, where we're going to start working on things. Now remember, they have to be numbered properly. So remember, there's progress bar 1, 2, 3, and 4, and there's button 1, 2, 3, and 4. So all we're going to do is change the numbers of the stuff. So progress bar 1 position, this is going to be 2. This is going to be button number 2. And then we're going to go down through here, make sure progress bar 2 is selected, and then make sure button 2 is the one we're passing to our other thing. And then on button number 3, we're going to do the same exact thing. So you're just going to make this 3, 3, and then, put 3, and then button 3, and then come down to 4, and we're going to do the same exact thing. We're just going to put number 4, and then number 4, and then number 4. Make sure we don't accidentally mess up on anything. So it's button 3 and 4. Okay, great. Looks great. Let's run this and just see what happens. Okay, guys? So here you have it, and we're just going to go boom, 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 boom. Now we have 4 threads all running at the same time, and nothing messes up the graphical interface. It's beautiful. And look, all the threads update in real time. How cool is that? And see now that they're in reverse order. It doesn't matter. They're all in memory. Everything's perfect, and it runs like a wet dream. Whatever. But there you go, guys. So that's how you would do a simplified multi-threading application that can update the graphical interface. The TTask stuff automatically synchronizes as long as you call another procedure. It's already built into the system.threading unit. It makes for a really, really, really fast, slick way of multi-threading without having to do too much effort. I know some of you might be looking at this like, that's little effort. Like, bro, you had to create a procedure for this and that and this and that. But if you think about it, if you're sat here designing some major software, I mean, it's actually going to be a pretty good idea for you to have different things like this, the enable button and whatever else, because they can be used for multiple purposes. You see, I passed the T button object name to this, and it handles whatever I told it to. I didn't have to create a different thing for button 2, 3, and 4. I just told it, no matter what, just enable the button. That's it. And I just passed the button in as a parameter. So by doing it this way, you can actually get really far with very little code. And you can take this as far as you'd like. You could make a procedure to handle nearly all of this in one thing if you really wanted to. So again, I'll give this one last run just so you guys can see. This is the TTask example in Delphi, and it allows you. I've gone over the ability to create a queued thread that runs in its own thread. And it updates the graphical user interface with a method called synchronize. But here's the thing. It's hidden from view. Like in this particular case, the TTask handles synchronize under the hood, so you don't have to worry about it. Now in the next example I'm going to show you guys is going to actually be an actual multi-threading example, and we are going to use synchronize ourselves to be able to do this stuff. So I'm going to run this again. Just real quick, just so you guys can see, I'm going to go start, just kind of start them out of order. And as you can see, they all go in the proper order, and they update the graphical interface at the end. It's perfect. See, boom, 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 boom. And you can drag this around, and notice how there's no lag whatsoever. It is very fluid, very, very awesome. Just boom, 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 boom. This can happen like hundreds. You could have hundreds of threads running and shit. Especially if you were writing like a network-based application where you're doing like a bunch of streaming, like say audio streaming or image streaming, you guys could actually stack up a bunch of threads to handle the workload, and your application would still be really smooth on the graphical interface, and it wouldn't look like it was really having to do much work, because all the work is being done in the background by the worker threads. You see it's really, really very slick, very smooth. See that? There's no lag, no nothing. It doesn't cause any freezing or distortion of the graphical interface whatsoever. It's really cool. But that is that, and I'll just let this run down. 3, 2, 1, 0, boom, there you have it. Perfect example. All right, guys, I'm going to go ahead and get started on showing you the next tutorial, which is actually going to be a multi-threading example. So just stay tuned. All right, guys, second part of the video. This is the part where we're going to actually learn about actual multi-threading in Delphi. Now, I've shown you how to use TTask, which is just kind of a cheap out method for lazy Delphi developers who don't really want to create a thread by themselves and create a constructor and a deconstructor and an on-execute event procedure for the thread and a private and public declarations, designing your literal own thread. A TTask is just a simple way to cheap out and let Windows control the thread. But in this particular case, we're going to write the same program again, but this time we're actually going to create our very own TThread class. And we're going to literally create it from the ground up. And we're going to manage it in memory. We're going to make it update the graphical interface via the TThread synchronization method. And then we are going to properly ensure that it gets terminated and all of the information that's running in memory that needs to be cleared is cleared. Everything gets fully updated on the graphical interface, on the GUI, and the thread properly gets terminated from memory. Okay? So to get started, let's go ahead and let's just go ahead and apply a theme real quick. So go Project, Options, wait for this to pop up, and as soon as it does, we're going to go with probably Ruby Graphite for a theme. So let's just click on this, look around for Ruby Graphite. So it'll be around here somewhere. You guys are more than welcome, by the way, to go with whatever theme that you would like. Me personally, if I can't find this, I'll just also go with like Red Rock or something. So I'm going to hit save, and there you have it. At least we got a little theme to look at now. And then we're going to grab a progress bar. So let's grab a progress bar, throw it down on there, copy, paste, paste, and paste. Now we've got 4 progress bars. We're going to need 4 buttons to go along with this, just like in our other applications. So put this there, pull that out. I'm going to drag these over to the side as far as I can get them so they look nice and pretty. And we're going to bring that up. Make sure the caption on this button is start in all caps, just like we did before. We're going to copy that. We're going to paste it. We're just designing right now, guys, so just, you can pause the video if you need. Just get it set up exactly like I've got it, okay? And we're going to grab ourselves another label, and we're going to toss it down below. The label looks a little small to me. I'm going to go ahead and increase the font size. You guys can do the same if you want, or not. Doesn't really matter. So there you have it. That's label 1. And I am going to make sure that this project is saved. For the caption of this, I'm going to put active threads and a count of 0 because we don't have anything going on to begin with. I'm going to make sure that the border icons are just simply closed. We're not going to have a minimize or anything else. We're going to change the border style to single, where it can't be resized, and then that's pretty much it. Okay, guys? Now, we're not going to use any components here other than the progress bars, the label, and the buttons. Everything else is going to be done in code. So we're going to go a little bit deep in this one just to create a thread to manage all of this stuff. So really try to pay attention. I'll try to be really slow about it and try to explain every step and everything that we're doing as best I can. I really hope I'm doing an okay job for you guys. I'm trying to make it easy. So to get started in doing something like this, we're going to essentially have to create a class type for the TThread. Okay, so we're going to go into our code, And the first thing we're going to do, let's just get a couple of quick things out of the way, because we are going to be using min like in the last portion of this video when we did the other stuff for the progress bar. So that requires the math function. So I'm just going to put that in there so we don't get errors later down the road. Another thing that we're going to want to do is we are going to want to put in, let's go ahead and just put system.threading, just in case we need this. And also we are going to put in system.syncobs for sync objects, because we're going to need that too. I see that common controls was already added, so I'll just erase this, no big deal. And there you have it, guys. So now you should have the same uses statements that I do, so we can start programming, okay? So to get going, we're going to create a type, if I can type correctly. Okay, so we're going to create a progress thread. We're going to call it a progress thread, because when we click the button, any of these buttons, we want to create a new thread in memory that's responsible for updating the button's corresponding progress bar all the way to 100%. Okay, so that's button 1 goes to progress bar 1, button 2 goes to progress bar 2, button 3, progress bar 3, and button 4, progress bar 4. You get the point. Okay, let's go back to this, and we're going to create a progress thread, which is going to be equivalent to a class of type TThread, just like that. And inside of this class, this thread that we're creating from literal scratch, we're going to create a private declarations area, and we're also going to do a protected and a public. But before we get down to that, let's just go ahead and write in some stuff that we know we're going to need. First of all, this thread is going to have to be able to lock onto a progress bar, and it's also going to have to be able to inject or update the integer position value by which that progress bar increments from 0% to 100%, which is an integer. So let's go ahead and say the progress bar is a type progress bar in Delphi. Then we're going to say an increment integer. So it's an integer. And just so you guys know, the reason I put F in front is just so that it's just something that helps me, like for the progress bar we're messing with, for the increment we're messing with. You kind of get what I'm saying. It's kind of weird, I know. I have a weird way of programming, I guess. I hope you guys can understand that we can't just put progress bar because it's not going to be a declared thing, if that makes sense, okay? So we have to make our own like little naming convention for everything that the thread is going to be able to control and update in our code. So we're going to use F progress bar is a progress bar type. F increment is an integer that we're going to be upgrading, or not upgrading, but using to increase, if you will, the progress bar's position. And then we're also going to create a critical section. So I'm going to cover critical sections in this too. So right now I'll just do a little bit of explaining. Let's say that you have 10 million threads going at the same time. God forbid. But let's say you did. Let's say that these threads are all updating the same exact thing in memory. Now that is going to be a bad, bad situation, because you've got 10 million threads and they're all doing the same thing to the same thing, or something different to the same thing. Let's say it's like an integer variable that has to first be grabbed by thread 2,998,000, whatever, and that thread has to do something with it before any other thread has access to it. Now, with millions of threads going, that would be an absurd situation, but you get my point. A T-critical section, or critical section, will allow the thread that is currently responsible for doing something with said variable to do its work, finish, and then pass it on to other threads so that they can use it. So by using a critical section, you're keeping your code perfectly secure and safe, thread safe. It's called thread safety. It allows your thread to do its work with whatever is needed, complete its work, pass that message on to Microsoft Windows and say, hey, yes, I am indeed finished, so other threads can access this safely now that I'm finished with it. You see what I'm kind of getting at there? Okay, so we're going to say f critical section is going to be equal to a t critical section. All right, so we have the progress bar, which we're going to be messing with, the value that we're going to be making it increment by, and we have a critical section so that we can keep things safe. Just so you guys know, honestly, the critical section truly isn't necessary in this type of application. I'm just putting it there because we're going to cover it, because I wanted to try to give you guys the best overview of multi-threading in Delphi that I possibly could. So, now that we have created our type class TThread, we've created our thread class, we've got a private declaration. These are all private, only to be used within each and every thread that gets created. And now we're going to create something else. We're going to create a protected procedure. And this procedure is going to be called execute. And we're going to override that. So what this does, and if this says unsatisfied, yeah, it's because I haven't coded it yet. But just understand, guys, that this execute thing right here executes the thread that we're currently going to be creating and messing with. So every thread that executes has its own execute override procedure. So every thread has its own execute procedure, okay? Because obviously you can't just have one execute procedure to execute a million threads. Like, you need each one to actually host its own execute procedure in memory. You see what I'm trying to get at? So for every single thread that executes, it has its own execute procedure and its own stuff that's going to happen in that. So now we have on execute, and now we're going to have a public declarations thing here, and we're going to create a constructor and a deconstructor. So let me explain that real quick. A constructor, let's say that you're writing an application for like a database or something, like a really big application for like accessing a database and updating customer records and putting in blob streams with images and stuff into a database and being able to delete stuff and move stuff and make new tables and rows and columns and all this crap. And let's say that, if you're doing this over time, as a developer, you don't want to have to sit there and code 20 lines of code to create a connection to the database, be able to SQL query into it and do stuff. Like, you don't want to have to constantly code the same old crap over and over and over. It's meaningless. It's fruitless. You're going to sit there for hours writing code that you didn't never have to write. All you had to do was write it one time. So a constructor is used for this purpose. In a constructor, you could create the component or the library connection thing that allows you to connect to the database. So you construct it and then use it in your code wherever you need with just one line of code every time you need it, which is great. And then when you're done, like let's say your application is done accessing the database, you just call its deconstructor. You just deconstruct it and destroy it, and it frees up all the memory for all the stuff that you had. So it's a really, really awesome thing to have. And that's what we're actually going to do in this situation. But in this situation, we're going to be constructing the progress bar, a progress bar, and the increment by which we're going to be upping the progress bar. So under public, we're going to create a constructor. So the constructor keyword is used. We're going to create this constructor. This constructor is going to be a progress bar, which is a type of T, progress bar, and then a increment, which is an integer, right? And then we're going to come on down and we're going to do a deconstructor. That is, if I can actually spell my wording correct, destructor, like that. And we're going to call this destroy. And this is going to be an override. So now that we have this, our entire thread code is created as far as being able to have its class and all the stuff we're going to be using inside of our thread. So we've got our private declarations, our private, or you can call them private variables that are going to be used only for that thread, right? And then we have our procedure on execute, and we construct the progress bar and the increment integer value by which we're going to be messing with it the whole time the thread is on. And we have a destruction, a deconstructor for destroying this and basically the thread in general. So now that we have our data structure, more or less, it's time to actually start programming, okay? And don't worry, guys. The reason these are red is because I haven't written the code down below, so it's not satisfied with this stuff. So, see, it's unsatisfied, because we haven't created the thing down in the code yet. But we're going to go ahead and start that now. So, let's go ahead and pop on down to where we're going to actually be writing below implementation here. And we're going to create our progress thread and stuff. So let's pop on down just right below this, and we're going to say, we're going to create our constructor here. So constructor. Good Lord, if I can spell today. There. And then we're going to do tProgressThread.create. And look, it automatically fills it in for us because I already wrote the code up here. So that's that. And then we're going to do begin end inherited create false. So now what this essentially does is create the thread in a suspended state. So now we're going to set this thread to terminate when it gets freed. So we're going to say free on terminate is going to be equivalent to true. Automatically free the thread when it terminates. Then we're going to say the fProgress bar is equivalent to a progress bar. Okay? Then we're going to say the fincrement is equivalent to a increment. Then we're going to put fCritical section is equivalent to tCritical section.create. And that is pretty much it for the constructor. So this is creating the thread. We're creating a constructor to create the thread and all the stuff and assign it so it's ready to roll, right? So now we're going to do the deconstructor. So destructor is going to be tProgressThread.destroy. We're attaching it to the destroy property of the or event rather of the progress thread that we created. So when the thread gets destroyed, something happens between the begin and the end. And in this particular case, we want to free the critical section. So fCritical section.free. It's inherited. So if I can spell correctly. So we inherit that from where we did up here. So now we've created the constructor and a deconstructor, and we're done with that crap, okay? So next up is to work on what happens inside the thread itself. So we're going to create the last portion, which is red, which is the execute event procedure of our thread. So down here below, just go right here, and we're going to put procedure tProgressThread.execute, and we're going to have a begin and an end. So we're going to say while the thread is not terminated, so while the thread is running in memory and not terminated, which means the thread is actively working, we're going to begin doing some code. So while the thread is running, we want it to do what? Well, we want it to simulate that it's trying to update a progress bar, right? So let's sleep for a little bit. Let's tell it 500 milliseconds, which is half a second. And this will give the appearance that something is happening with the progress bar. Animates it to 100% progress fulfilled, or whatever. So now what we have to do is we're going to synchronize, because here's the thing, guys. You got to understand this. This is a VCL application. This is a form. These are buttons. These are components, right? They're on the form. Now here's the deal. The form is a thread all by itself. It's known as the main VCL thread, which means the main thread of your entire application. Now, this thread is a standalone thread that handles all of the graphical user interface related stuff. So let me put it to you this way. And I'll try to really quickly open up Paint if I can. Let me just try to get this where you guys can see this a lot easier, okay? So this is your form, right? And you've got your little stuff in here, and you got your buttons and whatnot, and you got your little label. So this is the main VCL thread. So this is your main VCL thread. And if we create, so like in the background, if you create a thread for this progress bar, you know, and you create a thread for this progress bar, and you create a thread for this progress bar, and you create a thread for this progress bar, these are threads. Okay, this is a thread, this is a thread, this is a thread, and this is a thread. Now, each one of these can do anything in the world. You can make it do whatever you want. You can make it write whatever code you like. It can do anything. Anything in the world. Doesn't matter. Could be socket connections, could be connecting, could be grabbing people's Chromium passwords for all we care and sending them to whatever server in the world you want. Doesn't matter. But if it tries, if these threads have to do anything with this, if they have to touch this for any reason, if they have to touch the button start, if they have to touch anything on this, you have to perform something called tthread.synchronize. This has to be done in order to update anything on that form. So if they're going to directly touch any buttons, any labels, edit boxes, combo boxes, radio buttons, check boxes, anything on this thing, anything, they have to call synchronize. Because if you don't, you're going to thread lock your application. What does that mean? You guys have probably had things happen before to you in the past where a window turns white and says not responding. That's exactly what's going to happen, okay? Like if you try to make these threads talk to this application's graphical interface without calling synchronize, you're going to have problems. You're going to thread lock your application. You're going to cause it to crash. You can cause all sorts of major problems. And depending on what you're doing in your code, you can even crash Windows. So be very, very careful with this. Tthread synchronize must be called in order to do this, in order to update anything on any graphical interface. Doesn't matter where it is. It could be Form 1, Form 2, Form 3, Form 4, Form 5, whatever. Doesn't matter. You have to use synchronize in order for it to work. So let's get back to our code. Now, we were on the on the progress thread execute. So this is the actual thread as it works. So we're going to sleep for half a second, just to give it kind of a loading time frame appearance while the progress bar is being animated. But in order to update the progress bar right now remember what I just taught you. We're trying to access the main GUI now from our thread. So we have to tell it, hey, look, we're going to synchronize with you here. We're going to work with you. So we're going to have to call synchronize. So we're going to do tthread.synchronize. And we are now going to synchronize with it. We're going to put nil for the first parameter. And we're going to go down like this, put that there. And then we are going to put an end here. And we are going to put a procedure begin. So there we have it. So now we're inside of a synchronizational procedure. So anything inside of this end and this begin here will be synchronized with the main graphical user interface in a thread-safe way that won't cause the application to freeze or stall or cause issues and errors and all sorts of other BS crap, right? So we're going to say if the progress bar, so we're going to say if fProgress bar dot position is less than 100, so while it's still loading up to 100% in the progress bar, then we're going to say fProgress bar dot position is going to be equal to minimum of fProgress bar dot position plus fIncrement 100. So then we're going to do it. We're going to increment the progress bar all the way to 100, timing out in between for the sleep until it is 100. Else, if it's already at 100, we're going to terminate this thread. See what I mean? So now, get this, one last step. At the bottom of this code, while the thread is not terminated, it does work. But here's the thing. At the end, when it is terminated, so down here on this last endpoint, we're going to put form1 dot thread terminated. So on this, we're going to have to create a procedure for thread terminated, okay? Because it wasn't part of the TThread class automatically written in Delphi. So what we're going to do, let me just explain, okay? While the thread is not terminated, we're going to update the stuff. We're going to load the progress bar to position 100% increment or whatever, and it's going to look like it's being animated because we're sleeping half a second load, half a second load, half a second load, half a second load. And we're doing this by 10, by the way. We're going to be doing it by 10, and I'm going to show you that really shortly when we do the button. But whenever the thread is terminated, we have to clean up our act. You see what I mean? So like on this, we're going to create a procedure for this. So let's go ahead and do that right now. So at the top of our code, what we're going to essentially do is look around for our public declaration. Sorry guys. So right here, we're going to make a new procedure, and this is called thread terminated. Okay. We're going to copy this, and we're going to scroll down, and we're going to figure out what we got. So this is on form create. I'm not going to worry about that for now. We're going to go procedure tform1.thread terminated. So this is our cleanup portion. So when the thread does get terminated, we're going to come down here, and we're going to do some cleanup. We're going to clean up our act. We're going to make our GUI work. We're going to do all this stuff. So in order for this to work, we need to decrement our active thread count and update the label. So what we'll do is we're going to say decrement active threads, and we're just going to make a new thing called this, so because we're going to update the label. So we're going to say update the label to show one less thread because one just got terminated. Now I know that's red. We haven't designed it yet. No big deal. Don't worry about it, guys. We'll figure this out. We're going to say if progress bar 1.position is greater than or equal to 100, then begin, and we're going to do some stuff here. So we're going to do this one time and just copy and paste. So if the thread responsible for the progress bar 1 has already completed, and obviously it probably will, then we're going to say that the button 1.enabled will be equal to true. Now, this is the same exact code for button 1, 2, 3, and 4. So all we have to do is go 1, 2, 3, 4, and that code is completely finished. We're done. It's that simple, guys. So button 1, and remember, change progress bar 1 to 2, so everything goes 2, 2, 3, 3, 4, 4. So there's 1, there's 2, just kind of focus with me here, guys. This is 3. This is 3. And this is 4. Okay? So there's 4. All right, we're going to save that. And this right here is going to be us having to create another procedure to update that that thing. So what we'll do is above here we can create another procedure, and we're just going to call it tform1 dot update active threads label, like we did down below, and we'll do a begin and an end. Now this has to be done up here as well. So in the public declarations, what you want to do is basically make another thing here, the same as we did before. So just do procedure, and boom, and that's literally all there is to it. Okay. Just make sure that we spell it correctly. Let me try to go back up here and make sure I paste that exactly like that. And then this one here can be changed to decrement active threads, okay? So now inside of this, we want to program the label to update the active amount of stuff. So we want to say label1.caption is going to be equivalent to active threads, and then we want to do plus int to str, and we're going to do f active threads, and that's pretty much that. Okay, so we're going to save that. And this, for our active threads here, we should have actually put another public declaration, which I did forget to do in the beginning. This is just going to be like a how do I put this? It's just going to be an integer, and we can put it in public or private. I'll put it in private. So just put right here, just simply put f active threads as an integer. This is just a number that's going to keep up with all the threads during the program's runtime. Okay, really simple stuff. Okay, guys, make sure there's no errors in our code. Everything looks good. Okay, let's hit save. So now what we have to do is we got to start programming our buttons. So whenever we do this, let's go ahead and click on the first button, which is start on this button 1, and we're going to start programming. So to do this, we will put, first of all, we're going to reset the progress bar to position of 0 in case we are restarting. So just put progress bar 1.position is equal to 0, and then simply go down, and then we're also going to disable the current button that we're clicking on. So we're going to say button 1.enabled is equal to false, and then I'll put in a comment there, disable the current button that we just clicked. The thread will terminate once finished and re-enable the button for us. So there you have it. So now that we've reset the progress bar to position 0, because remember in our thread count, we want it to be up to 100%, but if it's already at 100%, the thread will just terminate and then it will update the button automatically. We don't want that. We want to make sure that the progress bar's position is back to nothing, so it can actually go through its processing with the thread like we want it to. So now that we've done this, we want to create and start the thread. So create and start our thread process, or well, I'll just leave it thread. So once we've done this, tprogress thread.create, and it's asking us for a progress bar and an increment integer value. So what we're going to simply do is we're going to say the progress bar that we desire to change, which in this case, since it's button 1, that's going to correspond to progress bar 1. And the increment value that we're going to increment by is going to be 10. So it's going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? So we're going to create the thread, and we're going to then increment or add to our f active threads. That's going to be added to that label down here at the bottom. Here, I'll show you this one right here. So we just update, we increment that by 1. So if it starts at 0, which it does, then it'll be incremented. And then what do you guys think is going to be next? We have to update the label, right? So we have to update this to show how many threads are running. So down below this line of code, we're going to actually write in update active thread label. So now that oh, and we actually called it something different. We actually called it I think we called it decrement active threads, if I'm not mistaken. Let me click on this and see what we actually did. Yeah, we called it this or whatever, but I mislabeled that a little bit. In fact, I'm gonna fix it. Let's put this here and try to correct this, because we don't want that looking stupid. Okay, so now it looks decently well. Let's do that. Okay, there you go. So now it's update the active threads label. So it'll actually show, the label will actually update with the latest integer value of how many threads are actually running. So guys, let's run this program just for shits and gigs, just to see what's happening so far. So let's change its position to the center of the screen, and let's give it a run real quick. So it's running. Let's click on start. It's got one active thread. Looks like that thread is working in the background to make the thing go to 100. And it looks like it did work. I just forgot one line of code, which doesn't surprise me. Basically, what you have to do is you have to update this label in the proper place. So if you'll take a look here real quick, it looks like I tried to actually update it here, but the problem, guys, the problem is we never decremented it. We never decreased the value. You notice my mistake, guys? Here, let me see if you can spot it. Spot this. You see my mistake? Watch. If I click start, everything works. We got the thread count. We got the thread in the background working in Microsoft Windows to upgrade this, and then it does it, and it re-enables the button, which is perfect, but this didn't change. So what did I miss? Can you guys spot the error? Pause the video now and see if you can spot the error. If you can't, so whatever, I'm going to go ahead and show you guys the answer. The answer is I didn't decrease it. See, I increased it here whenever we actually start the button click, like we click the button and we update and everything and blah, blah, blah. But whenever we were terminating the thread, I never decreased the value. So we have to decrease the value of active running threads. So we're going to say, we're going to have to put decrease. So decrease f active threads. And then we're going to update the label. So let's try giving this a go, okay? So I'm going to run this, and we're going to click on start. And now, as you can see, we have a thread running in the background. It's updating that, and boom, and now it works. That's the perfect code. This is multi-threading. So let me go ahead and copy this. We're going to copy the same code on the button. So I'm just going to copy from begin down to end. I'm going to copy that, and we're going to do that on the button 2, 3, and 4. So here's the button number 2. Same thing. And then we're going to go to the same thing on this one. And then we're going to go to the same thing on this one. We're just going to paste the code. Now we do have to go and edit just a couple little things, just the names of the components, okay? So what we'll do is go here. And since this is button 2, everything needs to represent number 2. So progress bar 2, button 2, you get the point. 2, 2, and that will be it. And then 3, we're going to do the same exact thing. It'll be progress bar 3 and button 3. And that is that. Also, don't forget, we do have to be upgrading the correct progress bar. So this is 2, 2, 2. This is 3, 3, and 3. And then 4 will be the same. So don't forget to put your numbers in the proper place, guys. Rename the components as needed. So this is 4, 4, 4. And that is that. Save that, run this, and let's go for it. So now I will start. We got 4 threads running all at the same time, blah, 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 blah. They're updating the GUI rapidly, just going through, and then they're looping and they're ending. And then you can start them all over again if you want to, and it does it the same thing. So guys, that is multi-threading in a nutshell, in its most basic form. I hope that you guys learned something from this. I've taught you guys how to create your own thread via the TThread class. I've taught you how to create your own private variable declarations, such as critical sections, and as well as locking onto graphical components, such as the progress bar. You can basically take this and do whatever you want with it. You can expand on this literally as much as you want. This is extremely basic example. We have a protected procedure called execute for every single thread that gets created. We have a constructor and a deconstructor, and I've tried to explain what those do. I hope I explained well enough for you guys. And then we have just a simple integer to keep up with how many threads are actually active on our application. And then I've shown you guys how to call different procedures to update different things. I've also shown you how to check if a thread is terminated. So while it's not terminated, do whatever you would like inside of the thread. And I've also shown you how to synchronize a thread with the graphical user interface and have it update graphical components and stuff like this by using the tthread.synchronize method. So with that being said and done, I really hope you guys learned something from this. If you have any comments, concerns, questions, or if you just need a different example with different data types, I would be happy to make more videos showing you guys like how this stuff works on an even bigger scale if you need me to. But if you do need me to, try to leave a comment with a little bit more of a descriptive nature. Like, you know, hey Bit, don't just say, hey Bit, can you show another example how to use multi-threading? That doesn't really tell me much. How about instead, if you're having an issue with some code that you're writing, you know, you might say, hey Bit, you know, I'm trying to do like, I don't know, audio capture, screen capture. I'm trying to access like a database, and I've got like 10,000 queries running at the same time. How can I multi-thread the return string values from those? You know, something descriptive that lets me know what you're trying to accomplish. That way I can try to code it for you, okay? But other than that, I hope that I really helped you out with this, guys. So I've to sum this whole video up, I've shown you the TTask method, which is kind of a cheap out method for Delphi developers who just want to let Microsoft Windows take control and do multi-threading in that way. And I've also shown you the original way to do multi-threading in Delphi with T-threads, which give you more fine-tuned control over how you create your thread and all the stuff that happens inside of it, including its termination on its thread terminated event procedure, which you can create yourself and use to clean up your GUI and make things better looking and stuff like this and that. So anyway, guys, I'm not going to keep lingering on. If you have any questions, comments, concerns, like I said, post in the video comments, and I'll be happy to help you guys out with anything. Also, I am taking requests at all times. So again, if you guys, you know, you don't want any more examples on this, say you want an example of something else, feel free to ask in the comments. I'll be happy to assist you. All right, guys, until next time, peace out and have a good one.